Hi friends, so today we are moving into part 9 of module 1 of power generation, transmission and protection, which is a subject of 5th semester electrical and electronics engineering students under KTU syllabus. So today we are going to discuss two tutorial problems which are coming under module 1 of economics of generation, load factor, diversity factor, load curve, etc. Those problems will be discussed. So let's move on to the tutorial 1 in which we are going to discuss the first question. So in the first question, let's read the first question. A generating station has a connected load of 43 megawatt and a maximum demand of 20 megawatt. The units generated being 61.5 into 10 raised to 6 per annum. Calculate first one the demand factor, second one the load factor. So let's start solving the problem. A generating station has a connected load. So first of all, let's note down the given data. So the given data, first one is the connected load. Connected load is equal to 43 megawatt. Okay. Secondly, the maximum demand. The maximum demand is equal to 20 megawatt. Okay. The units generated is equal to 61.5 into 10 raised to 6 per annum. Okay. Now we are asked to find first one the demand factor. What is the answer for the demand factor? What is the value? So first you should recover the value, the equation for demand factor. Demand factor is equal to maximum demand divided by the connected load. So the maximum demand is given in the question. It is equal to 20 megawatt divided by what is the connected load? Connected load is equal to 43 megawatt. So dividing both, you will be getting the answer as, what is the answer? 0.46. And this will not be having any units as both the numerator and the denominator are having the same units. Let's go on to the second problem in this one, second subdivision. You are asked to find what is the load factor. So what is meant by load factor? The equation for load factor is average load divided by the maximum demand. Average load divided by the maximum demand. So how can we find the average load? It is not given in the question. So first we have to find out what is the average load. It is given in the question that the units generated is 61.5 into 10 raised to 6 per annum. So what will be the average load? Average load is equal to number of units generated, okay, divided by the number of hours in 1 year, as it is given that the generated units is in 1 year. So we have to divide by 8660, which is the number of hours in a year. So what is the answer for this one? Number of units generated is 61.5 into 10 raised to 6 divided by 8760, which is equal to 7020.5 kilowatts. Okay, so much kilowatts. Why? Because units means kilowatt hour divided by hours. So you will be getting the answer in kilowatt hour. Sorry, kilowatt. Now what will be the load factor then? Load factor I am just writing as LF. LF is equal to average load divided by the maximum demand. Average load is found out as 7020.5 kilowatts divided by what is the maximum demand? It is given in the question as 20 megawatt. Okay. Now here you have to note that the units here in the numerator and the denominator are different. In numerator it is given as kilowatt and in denominator it is given as megawatt. So you have to convert both into equal units. Either you can convert everything into watts Or if you're thorough with the unit conversion, you can just convert this megawatt into kilowatt. So how can we convert this megawatt into kilowatt? You have to just multiply with 10 raised to 3. So 7020.5 kilowatts divided by 20 into 10 raised to 3 kilowatts. Okay, and your answer becomes 0.351. So now we have completely solved the problem. The answers for our questions are: the demand factor is equal to 0.46 and the load factor is equal to 0.351. Note that these two answers will not be having any other units, as the numerator and the denominator are having the same unit. Okay, so let's move on to the second problem. So that's our first problem is finished. Let's move on to the second problem. So in the second problem, we are going to discuss the second problem. A generating station has a maximum demand of 25 megawatt and a load factor of 60%, a planned capacity factor of 50%, planned use factor of 72%. Find out the reserve capacity, then the daily energy being produced, and the maximum energy that could have been produced if the plant was running as per the schedule were fully loaded. Okay, so first of all, let's note down what are the values given in the question. First one is the maximum demand. Sorry, I'll be using the blue color. So the maximum demand, it is given in the question and it is equal to 25 megawatt. Okay, now the load factor, I'll just represent it as LF. Load factor is given as 60%. We will represent it as 0.6. Okay. The next one is plant capacity factor. Plant capacity factor is equal to 0.5. It is given as 50%. Okay. Now next one is plant use factor, which is equal to 72%. That means 0.72. Okay. Now we have to find out what is the reserve capacity first. So what is the equation for the reserve capacity of a plant? So the reserve capacity equation is equal to plant capacity minus the maximum demand. Okay. So first we should be aware about the plant capacity value and the maximum demand. In the question, the maximum demand is given, whereas the plant capacity we have to find it out. So first we have to find the plant capacity. From where we can find the plant capacity? So plant capacity can be found from the plant capacity factor, which is given in the question. Plant capacity factor PCF is equal to 0.5. It is given. What is the equation for plant capacity factor? It is equal to the average load or the average demand divided by the plant capacity. Okay. So from this equation, you can find out what is the plant capacity. Okay. Now from this finding out the plant capacity, we can substitute in the reserve capacity and find out the answer. So first you should be aware about this PCF that is given in the question, and then second one you should be knowing the average demand, but here it is not available. So now what we have to do, we have to find out the average demand first. So what is the equation for the average demand or the average load? Okay, so the average demand or the load can be found out with the help of the load factor, because load factor is equal to average demand divided by the maximum average demand divided by the maximum demand. Okay, so you can find the average demand from this equation. Load factor is given in the question as 0.6 and the maximum demand is given in the question as 25 megawatts. So from this you can easily find out the answer for the average load, and you will be obtaining it as 15 megawatt. Okay, it is a very simple calculation. Now we have to find out what is the plant capacity. So from the plant capacity factor we found out what is the we have to find out what is the plant capacity. So what will be the plant capacity value? Plant capacity is equal to, we have to substitute the average demand in this one. We have to take plant capacity towards the left hand side and the PCF towards the right hand side. So your answer becomes average demand value is 15 megawatt, divided by, what is PCF? It is 0.5. Okay. From this, you can find out the answer as 30 megawatt. Now we obtained the plant capacity value. So we obtained the plant capacity value now, and now we can find out the reserve capacity. Reserve capacity is equal to, what is the answer? Reserve capacity is equal to plant capacity, that is 30 megawatt, minus the maximum demand. Maximum demand is 25 megawatts. So what will be the answer? The answer will be 5 megawatt. Okay. So now what we have to do? Okay. Okay, so we can find out the reserve capacity like this. Now, what is the second question? So, second question is to find out what is the daily energy being produced. So, daily energy being produced, or the number of units which is being generated, can be found with the average demand, which we have already found out. So, the number of units generated will be equal to the average load or the average demand into the number of hours in a day, that is 24, which means your answer becomes 15 is the average demand, 15 megawatt into 24, which becomes 360 megawatt hour, which is equal to 360 megawatt hour. Okay, now we can find out what is the third one. Number of units will be always given in megawatt hour. The unit will not be clear. Megawatt hour it is. So third one, you have to find out what is the maximum energy that could have been produced if it was fully loaded and is running as per the schedule. So from this, you have to identify that it depends upon how much the plant is being used, or you have to depend upon the plant use factor. So the plant use factor is normally given by the equation actual energy being produced, okay, actual energy being produced in kilowatt hour divided by the plant capacity into the number of hours it is being used. So this number of hours is not available for us. So you have to find this value actually. They are asked to find what is that maximum value you will be producing, the plant will be producing if it is working as per the schedule. So this value we have to find. This PUF value is given in the question. It is 0.72, and the average energy is already being actual energy is already being found at as 360. So just substituting these two values, this is 360 megawatt hour and PUF is 0.72. Using that, we can find the maximum energy. So the maximum energy that could have been produced is equal to actual energy, that is 360, divided by the plant utilization factor, use factor, that is 0.72. Now dividing these two, you will be getting the answer as 500 megawatts. Okay, so 500 megawatts will be your answer here. Megawatt hour per day. In one day, the maximum energy that can be produced will be 500 megawatt hour per day. So this is how you have to solve the next problem, that is the second problem. Hope you all understood. Thank you everyone for listening. Stay tuned.